Does that make sense? So, but in the end, whatever variable you create, whether simple or complicated, we can factor it out. But if you settle for complicated one, you may face a rigorous mathematics to be able to factor it out. And that's why we prefer to go for simpler one. But whenever a question like this come up, where you are adding, your artificial variable should always be equal to one of that. Does that make sense?
If there are three variables,
I would never go there for this class. I understand what you mean. That would be for advanced statistics class. It's true. We do Jacobian transformation for more than three variables. That's a multivariable situation. That would be beyond the scope of this class. That's a good question. Okay, now I've solved for S2, right? I need to solve for X1, right? If I want to solve for X1, it's going to be Y1 minus, look at this. If I want to solve for this, Y1 minus S2. But I'm not going to write S2. What is S2? Y2. Can you see that? What has happened now? What has happened now, I've been able to express X1 in terms of Y1, Y2, and S2 in terms of Y1, Y2. There's a Y1 here. Do you know there's a Y1 here? Okay? There's a Y1 here just like it's like this. You understand what I mean? So it's not showing because Y1 here is raised to the power 0. So what we, and that was exactly what we were talking about. Let me show you. That was what I was talking about here. Take a look at this. You're given this. And when you have this, you solve for what? You solve for X1. X1 will be in terms of Y1, Y2. And S2 will be in terms of Y1, Y2. That's exactly what we've done. And after doing that, what is the next thing we're going to do? The next thing we're going to do is to plug in this guy and plug in this guy inside here. With that, what do I want to get? I want to get GY1, Y2. I want to get a joint distribution for new variable Y1, Y2. Now, I'm going to come here right now. Wherever I see X1, I'm going to plug in this guy. Wherever I see S2, I'm going to plug in this guy. Now, what do I have now? So I'm actually going to have this guy, mu1 plus mu2, okay? Mu1, instead of raised to power X1, I'm actually going to say raised to power that guy, okay? Then mu2, instead of raised to power X2, I'm actually going to say raised to power Y2, then divided by the X1, the X1 with the Y1 minus Y2 factorial, okay, and X2, Y2 factorial. But you know what? You know what I'm looking for? The question asks me, if you look at the question asks me, the question said, find the distribution of the random variable Y1. The question wants this, G of Y1. Of course, in this class. If I want to find G of Y1 and I have the joint, what am I going to do? I will do the sum because this is a discrete. I will do the sum of this guy, then Y2 will be the variable. Now, you know what I'm doing right now? I want to factor out Y2. I don't need you anymore. I'm marginalizing that. Can you see that now? And that was why I said, whatever, and that's why you see here, you actually see, if you come back here now, okay, that's what I'm saying here. Can you see this guy? Can you see that guy? Y2. So Y2 start from 0. Of course, if X1, if X2, if I want to know the range for Y2, since Y2 equal to S2, what is space? S2 is 0, 1, 2. Y2 also going to be 0, 1, 2. So Y2 is also going to start from 0 all the way to infinity. So here, I'm specifically about GY1. I want to marginalize right now. And that's exactly, now, we are here now. Can you see that? Now, if you take a look at this guy, that is where we are now. Now, I now want to sum, I want to marginalize with respect to Y, I'm looking for I want to do GY1. It means Y2 will be regarded as constant. anything y2 should be regarded as constant. Now, take a look at this. If you take a look at this guy here, what I have here, 1 second, I'm going to do this. If you take a look at this guy, because the variable, what is the variable here? The variable is y2, y1 will be a constant. I bring y1 out. Anything that is not y2, I bring it out. And when I bring it out, please pay attention. You're going to be wondering, where do I see y1 factorial? I deliberately put 1 factorial here. I put it here. They will cancel out. Why do you think I need 1 factorial? Because I'm targeting gy1, y1. Okay? I'm targeting gy1. So I put y1 factorial here. I put 1 factorial here. That will cancel out. I still have what I have. Can you see that? I now want you to pay attention to somebody now. Take a look at this guy. That guy is this guy. Y1 under combinatorial analysis. Y1 combination Y2 is Y1 factorial divided by Y2 factorial into Y1 minus Y2 factorial. Now, I need you to pay attention now. Please pay attention. If you take a look at all this, okay, it's the same thing as this. When you now, I need you to focus on this guy here. This guy here is actually looking binomial. Okay, this is what I did. Okay, exponential raised to power mu1 plus mu2 divided by y1 factorial, summation, y2 start from 0. Okay, now, if I actually put that guy out, you're actually going to see that here, I still have a mu1 y raised to power that and mu2. I still have this guy, mu1 raised to power this, mu2 raised to power this. Then if I put this guy here, I have to put this guy here so that this can cancel out. Okay, now divided by y1 minus y2 factorial, y2 factorial. Now, if I have, so if you take a look at this now, okay, so we are there now. So y2 factorial, that. Okay, now, if you take a look at this guy here, I have y1 factorial. If you take a look at this, if you take a look at that guy, from the fact that n combination r in statistics is n factorial divided by r factorial n minus r factorial. You know, from this, I can rewrite this. I can say that y1 factorial divided by y2 factorial, y1 minus y2 factorial is written as y1 combination y2. So if I want to write this now, I'm actually going to write E mu1 plus, let me write it here so that you can see very well. Okay, so what I have right now, okay, the g of y1 equal e raised to power mu1 plus mu2 divided by y1 factorial summation of y2 start from 0 to infinity. Okay, so that guy, y1 combination y2. Okay, then mu1 raised to power this minus that. Okay, and mu2 raised to power that. Okay, now when you take a look at this, can somebody remind me? That is looking like a distribution that we've done in this class. What is that? What distribution is that? Go ahead. It's binomial. Send me a message for extra credit. Okay? Extra credit. You have 1 point. Good job. Okay, this is a binomial distribution. Okay? This is a binomial distribution here. And let me tell you this. When you have a binomial distribution, of course, there's something if I have this. Now, let me quickly recall from binomial expansion. Do you know that in, note that if I have a plus b raised to power n, okay, I want to go mathematical. A plus b raised to power n is summation, okay, summation. So I n combination x, a raised to power x, b raised to power n minus x, okay, where s start from 0. If you take a look at what I have here, this is looking like that. Okay, let's see whether it's looking like that. It's like A here is like mu2, and you see, A is carrying S, one of these. This is carrying this, and B is carrying different between this. This is carrying different between that. So therefore, if I can write this as a plus b raised to power n, then I can also write this, okay, in this form. Now, all what I need to do is, what is mu? That means one of them will be mu1, the other one will be mu2. Does that make sense? So one will be mu1, the other one will be mu2. Now, in that regard now, so I'm actually going to say this guy here, summation, y2 start from 0, y1 combination y2, mu1 raised to power y1 minus y2, mu2 raised to power y2. I can rewrite that as mu1 plus mu2 raised to power y1. Now, let's take a look at this. Y1 here is behaving like an n. See, y1 is n, right? X is y2. Look at that. Okay? Y1, this is like y1, this is like, so we're using, since this got from theorem, this is not from binomial expansion, if a plus b raised to power n equal to that. So in this case, my a is actually being introduced. You can see here a raised to power s, right? What is here? So here, mu2. So my a is mu2. So that's what I mean. A is mu2. B is y1. Okay. So that is what I mean. A is let me see. Oh, sorry. A is mu2. Okay. And B is mu1. Okay. Look at that. A is mu2. Let's see. A is carrying S. A here is carrying this, right? This is carrying this. Then what is carrying Y2? Mu2. Mu2 carrying Y2. Okay, so mu2 is your A. Can you see that? B is carrying different between this and this. And it is mu1 that is carrying different between that. Can you see that? And that is why I say, oh, that. And what is your N? What is N? We said this is the power N. What is the N? Y1. That's why you see raised to power Y1. Now, if I now want to rewrite the OT now, okay, so rewriting the OT now, I'm actually going to have the G of Y1 equal, so the G of Y1 equal exponential raised to power mu1 plus mu2 divided by y1 factorial, then the remaining one, mu1 plus mu2 raised to power y1. Now, this is the result. But you know what? Can we do something? When I was focusing on x1 the other time, I said it is this. Now, please, let's compare this with this. Okay, I gave you this one separately the other time. Please pay attention. I want you to see the difference. This is distribution for x1. When x1 follow Poisson, the mean is mu1. When x2 follow Poisson, the mean is mu2. But you know what this guy is telling me? Sum of x1 and x2, then the mean should be mu1 plus mu2. Compare this with this. What is the mean here? Everything here is a mean. Mu1 plus mu2. That's correct. Because this is for the distribution of y1. This is distribution of y1 equal x1 plus x2. It's like I'm adding the means. If you look at this is adding the, if the mean of this one is mu1, if the mean of this is mu2, then the mean of the x1 plus x2 should be mu1 plus mu2. If you compare this and this, okay, when you have a mu1 here, you're going to have a mu1 here. When you have this guy here, it's what you also have here. Just wanted to see the relationship they have, okay? But you know what? If you want to use the method of generating function, let's say what you want to use is the method of generating function. Please pay attention. Can somebody, if I want to use the method of generating function, y1 equal x1 plus x2, if I want to use the method of moment generating function, using moment generating function, okay, and y1 of t will be equal to what? The product of the moment, you remember? Okay, it's going to be the product of this one multiplied by this one. When I'm doing the sum, okay, the moment generating function of this will be the product of that. Now, if x1 follow Poisson distribution, can somebody remind me of what is the moment generating function? We did that in this class. We derived that in this class. Check your notes. Yeah, that should be exponential raised to the power lambda into t minus 1. So here, I'm going to say mu1. Okay? For this one, mu2 t minus 1. Check. Can you confirm that? Exponential, or when we derive the moment generating function for Poisson, I think we have exponential raised to the power lambda into t minus 1. Do you want to confirm that? That's what we have, right? Did somebody confirm that? Okay, thank you so much. Now, you're going to see what I'm going to do now. 1 second. Okay, now, I will indicate a mu1 here and a mu2 here because mu1, because I'm talking about x1. Now, I want to multiply this by this. Okay? I'm actually going to have mu1 t minus 1, mu2 t minus 1. Okay? So here, I'm actually going to have mu1 plus mu2 t minus 1. Please pay attention. There's something I want you to figure out. If this is the moment generating function for x1, the mean, what is the mean? Mu1, right? If this is the moment generating function for x2, what is the mean? Mu2. This is the moment generating function of x1 plus x2. What would be the mean? The mean is mu1 plus mu2. Can you see that? So if I want to use the method of moment generating function, I'm going to go by this. And the moment I arrive at this, if this has this as the PMF and this has this as the PMF, then I will automatically say this guy has this as the PMF. How? How do I know? Because the mean is, I'm only going to rewrite the distribution. I will rewrite the distribution. And wherever I see mean, I'm going to put mu1 plus mu2. Look at that. I want to rewrite this distribution. I'm rewriting it now. Instead of mu1 here, I put mu1 plus mu2. Instead of mu1 raised to the power x1, I put mu1 plus mu2 raised to the power y1. Because y1 is the sum, then divided by y1 factorial. That is how to use the method of moment generating function. Okay. If that is taken, I now want to move. Let me tell you this. The example that I want to consider now is for continuous. And the way we handle for continuous, using the method of transformation, is different. Jacobian will be involved. Derivative will be involved. Now, let's take a look at this. Okay, I'm going to walk you through this before I go today. Now, let S be a continuous random variable with probability distribution this. Find the probability distribution of y equal to 2s minus 3. You know, here we're only talking about 1 to 1. Now, please pay attention. If I want to deal with continuous, using the method of transformation, I will also find the inverse. You know, I'm giving y to be equal to I'll solve for x. If I'm dealing with discrete, I will also solve for s, and I will plug in that value. But here, after solving for s, I need to get Jacobian. For continuous, I need Jacobian. Now, you know what I'm going to do? What do I mean by Jacobian? Please pay attention. After solving for s, Jacobian will be the s dy. I will do the s dy. Can you see the s dy? I will perform the derivative here. After finding the inverse, I don't do the derivative when we talk about discrete. You know, in discrete, using method of transformation for one-to-one variable, what I'm just going to do is, after finding the inverse, I'm just going to plug in the inverse into the distribution. I'm done. But for continuous, after finding the inverse, I will need to find the s dy, which is the Jacobian. And after getting the Jacobian, I will need to find the absolute value. We don't want negative. Do you know what I'm going to do? I will come back to the distribution. Wherever I see s, I will plug in this guy, then multiply by Jacobian. I have to multiply by Jacobian. The Jacobian is 1 over 2. After plugging in that, multiply by Jacobian, this is my result. This is g of y. When I have g of y now, we know what I'm going to do. I need to determine the state space for y. Initially, you were given the state space for x. What I'm going to make use of these to get the state space for y. Plug in 1, 2 times 1, 2, 2 minus 3. That would be negative 1 here. Plug in 5, 2 times 5, 10. 10 minus 3 is 7. Therefore, the g of y is that, and y lie between negative 1 and 7. Done. The way we apply Jacobian transformation, the way we apply method of transformation when we're dealing with a discrete type situation is different from the way we apply it when we're dealing with a continuous type. But the only difference is there's only extended, approach, because you're still going to find the inverse, but you will need to find the s dy, which is the Jacobian. Then you're going to use the Jacobian to multiply the function after plugging in the expression for x. I'm done. Look at that. I'm done. Okay, so now I'm done with that. But you know what I'm going to go, where I'm going to go next is this. My TA is going to walk you through I put some exercise here. But in my next class, before I start the next topic, I'm actually going to walk you through method of transformation involving 2 variables to 2 variables. But that will involve, when I have 2 variables, that will involve a Jacobian matrix. Here we did not have a Jacobian matrix. So I'm going to walk you with that. Now, let me ask you this question before we go. I want you to try 7.23 for question A. They've given you the distribution, right? They want you to find the distribution of x plus y. You need what? You need an artificial variable. Can somebody tell me what artificial variable are you going to create here? U equal to x plus y. You want to figure out distribution of u. You can create v equal to what? Maybe some v equal to what? Maybe v equal to s or v equal to y. This is the same thing as, you asked that question the other time. But if I want to get the b part, did you say the b part? If I have x over x plus y, right? And I want to create an artificial variable, because if I'm working with 2 variables, I can't go from 2 variables to 1. I have to create another one. Now, please pay attention before I go. I quickly want you to see this. Before I go, I want you to see this. if you look at the second question, v equal x over x plus y, okay? You know, the first question is easy. The first one is easy. The first one asks, what is the distribution for u, right? So here, you can create maybe a new variable m and say equal to x or equal to y. That would be super easy. But here, what about a situation like this? I need you to pay attention. We have a rule here. You know, you asked about rule the other time. There are some that rule exists. If you take a look at this is looking like a proportion. Y. There's x here. There's also x plus y. There's x here, right? This is like a proportion. So whenever you want to create an artificial variable, it should be the one in the denominator. Here it's going to be x plus y. Here, artificial variable is going to be m. M can be any of that. M equal to maybe s or m equal to y. But here, artificial variable has to be the one in the denominator, which is x plus y. Do you want to try that before next time? They give you exponential for each of that. And they want you to figure out how you can use the method of movement generative function. You can use the method of transformation. But you know what? It is very easy to use the method of movement generative function here. Very easy. But there are situations where the method of movement generative function will be complicated here. And the only one that may work is when you use the method of transformation. And to use the method of transformation here, you need to create an artificial all the time. When you see something like this, artificial variable will be the denominator. All the time, if you see something plus y or something minus y, artificial variable is always going to be one of them. That's all I got for you today. Like I said, tonight you're going to receive makeup exam posted on Canvas for those who are interested. But you know what? The moment you finish and you log in and you log out, automatically you will receive your grade because it has been programmed. I wish you best of luck. Stay safe. Bye for now.